Okay, guys, so today I'll be going over two operating systems and two firewall systems and the security architecture and the hardening recommendations for these operating system and firewalls. So the two operating systems I'll be going over are Windows Server 2022, Ubuntu Server 24, and for the firewall, we'll be going over Windows Defender Firewall, and we will also be going over IP tables for Linux. So what exactly is a server? A server is basically a computer system, device, or program that provides services and data to endpoints typically called clients. They essentially the central provider for applications, files, things of that nature. When you think of file sharing, when you think of web surfing, this is the purpose of servers to provide those services to clients. When it comes to security, they are always on and they are always available, so making sure that the clients have availability and reliability of shared resources. However, the drawback to that is they are always vulnerable and they are common attack points for attackers. So we have to be able to harden them and make sure they are fully secure so we keep important information, secret and doesn't get in the hands of attackers. So let's start with Windows Server 2022. It's a secure root server, and what that means is that it uses hardware and firmware capabilities to protect against malware and other types of exploits. It uses a UEFI secure boot to ensure that the server boots only the firmware and software that is trusted by the hardware manufacturer. So anything that it does not trust, it will not be booted, which is good for the computer. And this standard protects the servers from malicious rootkits. Windows Server 22 introduces virtualization-based security, creating a virtual environment that isolates memory from the normal operating system, protecting sensitive credentials and keys. So essentially what that does is creates a virtual environment where it stores keys and pass keys that the operating system has no access to. So it's very, very secure. It uses TLS 1.3, which is transport layer security, and it's enabled by default to ensure connectivity for clients. So when you're sharing files, sharing anything, searching the web, TLS makes sure it's encrypted. And it supports DNS over HTTPS to encrypt DNS queries. DNS is just domain name server. That's how IP addresses are turned into readable names for us to see. Now, when it comes to hardening recommendations, for starters, it's always a good practice to remove all unused and unwanted features. This will limit the attack surface of the server and operating system, making it more secure, increasing the security for sure. When it comes to Microsoft, they have a Microsoft Security Baseline feature, which is basically a series of recommended and like foundational security practices that you can adopt to be sure that you have at least a foundation secured, and then you can add on top of that whatever you would like to your server and your operating system. This just gives you a foundation for security infrastructure of the server. Another one's to enforce strong MFA guidelines, is simply multi-factor authentication. So putting the password, not just the password, but also have a code for that, maybe biometrics, things of that nature. This is to ensure that only the right people have access to the right resources. It's good to log and monitor events on the server using sign management. They provide real-time analysis of security threats. You can log things in real time so you don't get caught off guard by things that happen. It's good to enforce policy rules for all users through GPOs as group policy. All users, whether it be privileged users or regular users, should be monitored to make sure everyone's doing what they're supposed to do. So no one has any access they shouldn't have, higher privileges that they should not have. So when it comes to Ubuntu Server 24, this is a Linux staple. It features unprivileged user namespace restrictions. All that means is it implements strict user permissions, kind of like I spoke about with the Windows. Users should have strict accesses. No one should be able to access privileges that they do not have access to. Everyone have their own privileges, right? Introduces App Armor 4. So App Armor is a staple application for Ubuntu. App Armor 4 is the latest version. This provides mandatory access controls and now includes the ability to specify allowed network ports and addresses within security policy. So whatever network ports would be port 80, port 22, that's SSH. If it doesn't want to be allowed, it won't be allowed. You can allow that. Utilize TLS again, Transport Layer Security 1.3, and the older versions are disabled to prevent downgrade attacks and to secure communication. The updated kernel 6.8 allows for advanced security features such as CPU-enabled security and hypervisor security, which provide protection for hypervisor attacks. That's that hardware security that I spoke about before with Windows. The central processing unit enabled security. Enabling security into the hardware is very strong technology. In case of hardening an Ubuntu server, once again, make sure you remove all apps that you don't really need, all applications, all services that we're not using. And once again, decrease the attack surface, decrease areas for attackers to exploit. Of course, update the system and ensure the latest security patches are installed. Disable root SSH access. This reduces the server's attack surface by preventing access to the most privileged account. SSH will allow for an attacker to connect and attack your server from anywhere, and that's not what you need. Disable password logins and mandate SSH key authentication. Configure PAM, that's a pluggable authentication module to enforce strong password policies. Strong password policies are underrated when it comes to security because rainbow attacks, all these different password attacks are a thing. And the more complex these passwords are, the harder it is to crack them. It's good to install Logwatch to automatically scan logs for suspicious activity for every server. Everything is good to install logs. They automatically review and monitor what's going on in real time, and it alerts you so you can know you don't react too late. And minimize attack surface, like I said, remove anything you're not using. No reason for it to be on, no reason for it to be in use if it is of no use. Now we move on to firewall. Start with Windows Firewall. This is a host-based firewall that is included in the operating system and is enabled by default. So it has network location awareness, meaning that it adapts its configuration depending on whether the machine is in a public, private, or domain network. It integrates with IPsec, enabling authentication and encryption of network traffic between hosts and ensuring that only trusted and verified systems can initiate communication. It's built on Windows filtering platform, which is a kernel-based engine that powers the firewall. It allows use of RDP from only trusted IP sources. That's remote desktop protocol, another option that allows people to control servers and computers without and without it, if it gets in the hands of the wrong person, that could be bad. So the attacker has remote control of your system, your server, your firewall in this case. It's not good. Traffic that enters and exits the device is filtered, so you know where it's coming from, maybe what port, what site, things of that nature. And use GPOs to help manage and configure inbound and outbound rules. So group policies, tells it, okay, this can come in on this port, this can't. This port is open, this port is not. When it comes to hardening, group policy to apply managed firewall settings across multiple systems. Implement trusted Microsoft security baselines, per usual. Implement the baseline security things. Create rules based on precise conditions for tailored security. Periodically review firewall configurations. Remove rules and adjust settings as threats evolve. We're going to leverage IPsec. So you get that secure tunneling when your data moving through a tunnel, so it's secure. Multi-factor authentication, once again, make sure you are who you say you are, basically, so we don't get attackers in. And reduce the attack surface, once again, basic standard. For IB tables, it's a Linux staple again. Very, very powerful, very, very powerful firewall, and it is very technical in nature, very command line heavy, no GUI, but it's powerful security. It has connection tracking. It operates using hooks, tables that structure what can come in, what can come out. Within tables, chain determine the packets are evaluated. So input, output, forward, pre-routing, post-routing. All these are things that just tell, okay, what is coming in, what's coming out, what can come in, what can't come in, and what goes out. Very, very powerful firewall technology. Very technical, though, I will say. Very, very technical. You need to have command line proficiency to use this. Hardening, adopt default deny strategy. So explicitly only allow what you trust. Only open necessary ports per usual. Log drop traffic with prefixes. Logging, always speak about logging. It applies something called fail to ban, which monitors and blocks IPs automatically. That's that logging again. It does automatically. That's what you need to do. A lot of good hardening techniques. And that's all for my presentation. Hope you enjoyed it.